In this video, we'll show a quick introduction to HYPERLAB, Nereos's software for analyzing hyperspectral datasets. To open a hyperspectral image, click on the button Add Image or drag and drop the dataset into the Hyperspectral Images panel. Datasets exported from the Nereos acquisition app contain a suffix corresponding to the type of measurement. As an example, let's open the raw intensity data. You can visualize the acquired image in the main panel and the details about the acquisition in the selected image panel. Moving the cursor over the image, in the spectrum panel you can see the live spectrum corresponding to the pixel under the mouse position. The pixel coordinates can be found in the lower right corner of the image panel. Using the spectrum panel on the right, we can change the brightness and contrast of the image. Scroll the mouse wheel to change the maximum and, holding the mouse wheel, move the mouse to change the minimum. On the Hyperspectral Image panel, you can click on the Data menu and normalize it by selecting Add Effect, Background Reference. Select the flat field data cube for normalization, which will be calculated automatically. The data will now have values between 0 and 1. You can add other effects to the image, such as spectral crop. This allows you to select a spectral range of interest and exclude, for example, wavelengths where you don't have any signal. Click on Apply to apply the effect. To automatically adjust the brightness and contrast, you can use the Auto Brightness and Contrast button. Another effect that can be applied is spatial crop, which allows you to select a region of the image and crop the data cube spatially. Click on Apply to apply the effect. Calculate the standard RGB version of the image by selecting it in the Display menu. To select a part of the image and correct for a white or black target, select White Target or Black Target in the Image menu. Select the spatial region and click Apply to apply the effect. Each effect can be disabled, enabled, or removed using the appropriate buttons. We can view a false RGB version of the image by selecting the option from the Display menu. We can now select which wavelengths to map onto the red, green, and blue pixels of our computer display using the spectrum panel. At any time, the current image can be saved as a .png with the Take Snapshot button. Labels can be created in the Labels panel. There are 3 possible selection tools to select a region of interest: rectangular selection. We also have brush selection, and we're able to change the size of the brush. And let's make one more label, rename it, and now we'll use the point selection tool. In the spectrum panel, you can see the spectra for the 3 different labels we've just created. The checkboxes here enable us to show or hide various features from the plot. The average of the selected pixels is shown as a solid line, and the standard deviation is shown as a shaded area. We can find more information about the labeled regions in the Selected Label panel. Current spectra can be saved as a PNG file with the Take Snapshot button, or as a CSV file with the Export Label Data button. You can also adjust the spectral range of the plot by dragging the ends of the wavelength bar here. Now let's take a look at HYPERLAB's ability to automatically classify regions of an image. Select the grayscale view of the image and go to the Classification panel. Here we can choose which algorithm to use in order to perform the classification. We can select which of our images that we want to be classified. And we also need to specify the input labels. Click on the name of the image to be classified to select the spectral range, or import it from the spectral panel by clicking on the Take Range from Chart button. Click on Classify to perform the classification. In the Overlay menu, we can overlay labels or classification on the image. We can also vary the transparency of the overlay. Classification with the Spectral Angle Mapper allows us to identify pixels with a similar spectral content. However, since it's a supervised algorithm, we need to select an appropriate acceptance threshold. The acceptance threshold can be varied by selecting a label in the classification panel and varying its angle threshold. You can save the current analysis session as a project by using the Save Project button. In this way we can open and continue our work later. Visit our website for more information, or write us, info@nereos.com.